So now I'm going to talk about 11.4, which is log functions, logarithmic functions. So if you recall that exponential functions, f of x equals b to the x, base is greater than 0 and not 1, it's a one-to-one function, meaning it passes the horizontal and vertical line test, so it must have an inverse. To find the equation of the inverse, of the inverse of f of x equals b to the x, we go through the 4 steps that we did for finding the equation of the inverse. First, replace f of x with y, switch x and y, and then solve for y. To solve for y, we have x equals b to the y. Y is an exponent. It's not going to be easy. It's not something we've done before or we could do using what we know. So we're going to have to come up with a new function, and we say y equals the logarithm of x to the base b. And instead of doing all this, we write y equals log for log of x to the base b. So it's like f of x or g of x, except log base b of x. It's like having a serial number. The base, again, same base as exponential. It cannot be negative, 0, or 1. So that means the inverse is log base b of x. So from all this, we learn two things. We learn that this and that are equivalent. This is called exponential form, and this is called log form. So let me rewrite this on a fresh page. So that's called fact 1. Exponential form, x equals b to the y, is equivalent to log form, y equals log base b of x. And you can see how to switch from one to the other. If you have the exponential form and you want to switch to log, so we need log, we write log base b equals sign, and we start at the base and we say b to the exponent, and the exponent is y, equals x, so we put x in there. And if you have the log form and you want to switch it into exponential, again you start at b, same thing, to the exponent y, so b to the y equal x, and you drop the log because now we're in exponential mode. So let's practice that. So how do you write log base 8 of 8 equals 1 in exponential mode? You just start at 8. 8 to the first one equals 8. And we know from this that log base b of any b is 1 because b to the 1 equals b. So we have a first rule of log. If the base and the input are the same, the answer is 1. Number 28, page 946. So if you're given log base 6 of 1 over 36 equals negative 2, all they're asking here is to write it in exponential form. So you start at 6 to the exponent. So 6 to the exponent negative 2 equal 1 over 36. We drop the log because now we are in exponential mode. Another example, if we have log form, how do we write it? I'm sorry, if we have exponential, how do we write it in log? So we write log, we put the base down here. Again, 3 to the exponent, negative 3 equals 1 over 27. Okay, now let's go to 54. from that section. What page is that? Let's see. 54 from page 946. So they want us to solve for x in this case. Log base 7 of x equals 0. Since we're not familiar with logs, we're going to change this into exponential. So 7 to the 0 equal x. So x must be, anything to a 0 power is 1. So x must be 1. 58. Again, same page. Page 946. Log base 3 of x equals negative 4. So 3 to the negative 4 equals x. 1 over 3 to the 4 equals x, which is 1 over 81. Again, log base 4 of x equals 1/2. So find x. So 4 to the 1/2 is x. Remember, that's the square root of 4, which is 2. And log base 27 of x is negative 1/3. Again, find x. Same idea. 27 to the negative 1/3 equals x. But that's a negative exponent, so we put it at the bottom. And that's a cube root, so which is 1/3. So now, more examples. This time x is in the base. So log base x of 5 equals 1. Same concept. X to the 1 equals 5. So x is 5. Number 70, page 946. Log base x of 100 equals negative 2. Again, find x. So x to the negative 2 is 100. And we know that 10 square is 100. But we need 100 under 1. So it's 10 to the negative 2 is 100. So x must be 10. In 78, x is the output. So log base 6 of 216 equals x. Again, 6 to the x power is 216. If you do on your calculator, 6 cubed is 216, so x must be 3. Okay. And if you have log base 4 of 8 equals x, so 4 to what power is going to equal 8? If we do 4 to the 1, we get 4. 4 squared, we get 16. This is undershooting, overshooting, so it has to be between 1 and 2. If you do 4 to the 3/2, this is square root of 4 cubed. 2 cubed, which is 8, so x is 3/2. So we just have to do trial and error. And log base 125 of 5 equals x. Again, 125 to what power is 5? That power is 1/3. Why? Because cube root of 125, which is 125 to the 1/3, and that's how we get 5. That's all based on the first fact. The second fact that we learned from the beginning was the inverse. Remember, we were finding the equation of the inverse of b to the x. So the inverse of f of x equals b to the x is f inverse of x is log base b of x, which we know domain for exponential is negative infinity to infinity. Range is 0 to infinity. So here they swap domain and range because they're inverses. So domain of log is 0 to infinity, and range of log is negative infinity to infinity. So basically we cannot do log of negative, right? It has to be 0 to infinity. So if I say find log base 2 of negative 3, you would say undefined. Can't have a negative, can't have a 0 in there. So how do we graph log functions? Graphing log functions. So there are two basic graphs of logs, just like exponentials, two basic graphs of logs. The first one, if the base is greater than 1, so we're doing f of x equals log base b of x. And in this case, let's pick any number greater than 1. So we're going to do y equals log base 2 of x. We're going to make a t-table, but we don't know how to plug numbers in, so we're going to switch it to exponential. We put y on this side. 2 to the y equals x. Since x is isolated, we're going to plug in values for y. The usual values we plug in for x, we plug now in for y. If we plug negative 2 in there, 2 to the negative 2 is a quarter, 2 to the negative 1 is a half, 2 to the 0 is 1, 2 to the 1 is 2, and 2 squared is 4. And if we do the graph, we get 1 quarter negative 2, 1 half 1, 1 0, 2 1, and 4 2. So it's going to have this shape. And any graph of log that has a base greater than 1, it's going to look like that. And I actually have this on the handout that has these handouts. So right there, you can see log base 2 of x versus 2 to the x, they're inverses of each other. And also it shows you the case. So this is one of them. And then this is where the base is between 0 and 1. I'm going to show you an example about that. So there are two important features for the log, 1 0 and a vertical asymptote. Okay, it's increasing. The vertical asymptote is the y-axis, which is x equals 0, and the x-intercept is 1. If you do one for the base between 0 and 1, case 2, if the base is between 0 and 1, I'll pick 1 half. So log base 1 half of x equals y. We'll do the same. 1 half to the y equals x. Remember, this is the same thing as 2 to the negative y. We went over this. So we're going to plug those values in. So we're going to get 4. 2 to the 2 to the 2 is 4. 2 to the 1 is 2. 2 to the 0 is 1. 1 half, a quarter. If you graph it, 1 2 3 4, 1 2, 4 negative 2, 2 negative 1, 1 0, 1 half 1, and then 1 quarter. You can see how it's going along the y-axis, which is an asymptote, as we know. X equals 0. It has x-intercept, but it's decreasing instead of increasing. And so that's based on the base. If it's 1 half, it's decreasing. I mean, if it's between 0 and 1, it's decreasing. If it's more than 1, it's increasing. Okay? So let's practice that. So there are two shapes for the log, the basic graph of logs. The first one, which is increasing if the base is greater than 1. We just did that. And the second one, it's decreasing if the base is between 0 and 1. Okay, keep that in mind. And the handout has both of these functions. So now 104, page 947. It wants us to graph f of x equals log base 1/3 of x minus 1. So this is decreasing, but it's down 1. So it's going to be going down, but it's going to be down 1. So 1 0 is going to be down 1 to 1 negative 1. And if you move the y-axis down 1, it's still going to be the y-axis. X equals 0 is the asymptote, but instead of going through 1 0, it's going to go through 1 negative 1 because it's down 1. So we just do our best, copy and paste. And if you look at 106, page 947, f of x equals log base 4 of x plus 2. That's increasing, and it's left 2. So increasing, but we have to move it to the left 2. So 1 0, if you move it to the left 2, it's 0 0, so it becomes negative 1. sorry, let me fix that. It becomes negative 1, 0, and then x equals 0. If you move it 2 to the left, it becomes x equal negative 2, and copy and paste. It's the increasing graph. Okay. Now there are two kinds of special logs. The first one is called common log, and the second one we'll do in the next section. Common log has base 10. So if you have log base 10 of anything, it's log of anything. We don't have to put the base if it's base 10, and your calculator has that key built in. And you can see in there log, and the 10 is in the background, so you can see it. So if you do log of 10, for instance, you're doing log base 10 of 10, which is 1, because the base is 10. If you do log of 1, that's log of 1 base 10, which is 0. So that key can be used if you're doing base 10. Okay, so if you're doing log like we talked about, log 10, that's equal 1, because remember there's a 10 here, and 10 to the first power, if you do it, change it into exponential, is 10. If you're doing log of 1, that's 0, because again 10 to the 0 is 1. If you're doing log of negative, any negative, it's undefined. Even your calculator is programmed to do that. Log of negative 2, and you can see it's non-real. Okay. If you do log base 10 of 10 to the x, again these are inverses of each other, so they cancel out and you get x. Again, because 10 to the x equals 10 to the x. Same thing if you reverse them. 10 log base 10 of x is x if x is greater than 0. Why? Because x cannot be negative, because you're applying that to log. So for instance, if you're doing log of 10 to the negative 2, remember here there's a base 10, so they cancel out and you get negative 2. And if you're doing 10 log base 10 of 2, again 10 and log base 10 cancel out and you get a 2. And if you're doing 10 to the log of square root of 5, remember that's base 10, they cancel out and you get root 5. If you look at your calculator, find log of 375.876, and they want 4 decimal places, so you just punch it in your calculator. Log of 375.876, it's 2.5750. So that's asking us to use the calculator. But if they say find y, and you have log of y equals negative 0.28. So I couldn't possibly do log of y because I don't know what y is. But to get y, I need to change it into exponential. When you're stuck with log, your savior is always the exponential. So 10 to the negative 0.28 equals y. And that's what you key in your calculator. 10 to the exponent negative 0.28. 4 decimal places, so it's 0.5248. And if they say find x, if log of x, 10 to the log of x equals 1 over 10, you know 10, log base 10 cancel out, so x equals 1 over 10. And that's the end of 11.4.